Welcome to the Williamson Ether synthesis lab video. In this video, I'll go over the reaction mechanism and then we'll go into lab and do the reaction. So here is the reaction. We have 4-ethylphenyl reacting with methyl iodide to make anise or methyl p-ethylphenyl ether. We have sodium hydroxide deprotonating our reactant. Since they are deprotonated, they stay in the aqueous layer. The anion is attracted to the positive charge on the phase transfer catalyst. Since the phase transfer catalyst has these nonpolar chains, it is able to take the anion into the organic layer. This is the only way that it is able to react with the methyl iodide, which is only organic soluble. This goes through an SN2 reaction mechanism to make our product anise. This is also the smell of black licorice. And then our catalyst can continue to be used up again. Let's go into lab. Here is our apparatus. We have a 5 milliliter conical vial containing a large spin vane. It's fitted with a water condenser. The vial is placed in a temperature monitored water bath at around 65 degrees Celsius. Both the conical vial and the thermometer are being suspended in the water to ensure a proper temperature reading. We'll begin by weighing about 150 milligrams of 4-ethylphenyl. So we've placed some of the reactant on the weigh boat, and it weighs 160 milligrams. We'll take off the water condenser to add in the 160 milligrams of 4-ethylphenyl. Now we're going to add 0.25 milliliters of 25% sodium hydroxide. The 4-ethylphenyl needs to dissolve before adding the phase transfer catalyst, tetrabutylmonium bromide, and methyl iodide. We'll begin by weighing about 15 milligrams of the tetrabutylmonium bromide. Since this is a catalyst, it is not critical that we get the exact weight. We'll now place the tetrabutylmonium bromide into the solution. Now onto methyl iodide. We want to remind you that this is a known carcinogen and to always keep the container in the ventilation hood. A micropipette is used to obtain the 90 microliters of methyl iodide. And the methyl iodide is added into the reaction vial. Now we will be at reflux for 1 hour. After the hour of reflux, we lift up the conical vial and let it cool at room temperature for a few minutes. At this point, we can take the water condenser off, and it clearly smells like anise or black licorice. We will use diethyl ether or ethyl ether as our solvent to extract the aqueous layer to obtain our product. Using a Pasteur pipette, we add a little bit of the diethyl ether into the conical vial that has our product. The Pasteur pipette can also help us mix both layers together. Diethyl ether is less dense than water, so we take the top layer out and place it in a new conical vial. We'll extract 2 more times and rinse our spin vane with diethyl ether to obtain as much product as possible. Notice that there is a solid in the solution. This is not our product, so we don't have to worry about it. Instead of mixing with the Pasteur pipette, we can use a cap and vigorously shake the vial. We will now wash with an aqueous base to remove any unreacted phenyl that may be in the ether solution. We'll mix both layers together, and then we'll take out the bottom layer, the aqueous layer. We'll now do one last wash with water to remove any excess base. Sodium sulfate is then used to dry the ether solution until the solid is free-flowing using a small Erlenmeyer flask. Once it is free flowing, we can place the dried solution into a clean conical vial. The ethyl ether is then evaporated using a gentle stream of air. After a few minutes of evaporating, you'll be left with about a drop of crude product. To purify our product, we use activated silica gel to retain any leftover 4-ethylphenol. 4-ethylphenol is retained because it is more polar than our ether product. Methylene chloride will be used as the eluent or the mobile phase of the column. We'll begin by dissolving our product with a little bit of the methylene chloride and adding it right to the top of the column. We'll continue to add methylene chloride until we have obtained at least 5 milliliters of methylene chloride with our product ether. We can wait for gravity to do the trick, or we can use a bulb to push down the methylene chloride through the column. We'll continue until we reach about 5 milliliters. The methylene chloride is then evaporated until our pure product remains. To obtain the weight of the product, we first weigh the conical vial. It weighs approximately 23.356 grams. And the weight of the vial and product is 23.365 grams. Since we have a liquid product, we will obtain a neat IR. An open capillary tube helps us place a few drops on the salt plate. We will then place the salt plates in the IR machine. And obtain our product IR. Remember, we have an ether as our product, so we should find a C to O single bond peak at 1250, and we should also have a peak at around 1050. We also have our benzene C to C bond peaks here.